Here in Chapter 8, we're going to talk about experimental designs. And the experimental designs can seem a little bit daunting because they seem very technical, but there are a lot of considerations for how we do experimental designs because we are, in fact, trying to determine if there is some cause and effect. So there is a lot of detail that we have to consider, but we're not going to get bogged down by the detail necessarily in advanced research courses. And if you're going to do an experimental design, you'd be doing a lot more research on the method of experimental designs. But here I want to introduce you to how we do experimental designs and some of the ways that we need to factor in considerations like order effects, counterbalancing, etc. So we're going to take a look at all of that, and keep in mind that we want to remain kind of in a broad perspective. We will look at some details and just some examples of how we organize our experimental design, but generally we're going to keep it fairly broad. Let's take a look at the objectives and get into the lecture. Few of the objectives that we have for this lecture is to provide a definition of what a confounding variable is and describe how they are related to internal validity. The good news is that we've already covered confounding variables somewhat way back in Chapter 2, so I don't think that this is going to be a lot of review that we need to go through, but it is something worth mentioning again so that we can resituate the confounding variable in terms of the experimental design. We're going to talk about the post-test only design and the pre-test post-test design, including some of the advantages and disadvantages. We're going to contrast independent groups and repeated measures designs. We're going to take a look at the advantages and disadvantages of repeated measures design and explain how counterbalancing can address the order effect problem. And then we're also going to briefly describe the match pair design when we have people that have certain characteristics that can be grouped together. So we're going to take a look at all those things here in this lecture. Let's jump right into confounding variables and internal validity. With a confounding variable, we are looking at ways that we can challenge the cause and effect in our study. Remember, the thing that we're going to look for in terms of internal validity are the order that the two correlations occur in. Said differently, we are looking for the temporal precedence, as well as the covariation of cause and effect, and eliminating plausible alternative explanations. So the confounding variable is something that can cause any kind of threat to determining internal validity that is leading to cause and effect in an experimental design. So a confounding variable occurs when the effects of an independent variable and an uncontrolled variable are intertwined. Let's say that we are doing an experiment where we are going to determine the effects of using alcohol on cognitive rationale. So we want to know if people can think through something when they have been using alcohol. A possible confounding variable is somebody who has an alcohol issue. Now forget about the ethics of it. Let's talk about somebody who might be desensitized to the effects of alcohol. Not to say, by the way, that people who use alcohol a lot are good at making decisions under the influence. We're just talking about people who unfortunately have had a lot of experience making decisions while under the influence of alcohol. But the confounding variable might be past alcohol use, because in some cases it could enhance, whether we like it or not, decision making. Again, I'm not suggesting that that's the case generally, and please don't hear me say that. But the confounding variable is prior use, and that could have an impact on the study. So the independent variable in this case would be the alcohol use for the individuals in the study. So if we had two groups, one was a control group, one was an alcohol use group, then the people with the alcohol use would be the one level of the independent variable. With a confounding variable, we also cannot determine which variable is responsible for the effect. So if prior alcohol use is a mitigating factor on the use of rationale, we wouldn't know. We would probably think that maybe the alcohol doesn't in fact have a different impact on rationale, on cognitive rationale. Unfortunately, it does, but if we had a case where somebody were using alcohol prior to that and had gotten used to the idea of thinking while under the influence, we might mistake that reason for the purpose of our outcome. So we have to be careful that we aren't accidentally attributing a confounding variable to the cause of our effect when in fact it is just a confounding variable. we have to eliminate confounding variables in order to determine if our results are internally valid or if they have some kind of causal relationship. There is an analysis called an analysis of covariance to determine if there are other factors that are influencing the outcome. And that's a statistical analysis. It's relatively straightforward, but it is something that is an advanced test anyways. Now, when we talk about a confounding variable, something that influences the outcome that is not related to the study, we have to differentiate that from what's called an extraneous variable. An extraneous variable could be something that is common among some people, but they don't have any systemic changes in the outcome of the study. For example, some people could use marijuana. And if those people are also in the study and they are using alcohol as part of the experimental group, the marijuana may or may not have an impact on the outcome. It depends on when it was used. But if it doesn't have an outcome on if it does not have an effect on the outcome of the study, then we will just consider it to be an extraneous variable. It's an interesting variable because maybe marijuana use is related to alcohol use in terms of it inhibiting cognitive functioning, but it doesn't appear to be a confounding variable in the study. Again, we can statistically control for things like marijuana use to determine if it has an impact in the study. But again, an extraneous variable does not become a confounding variable until it impacts the outcome of the study. And the confounding variable relates to internal validity. Again, this is kind of review, because internal validity is the ability for us to trust our results within the study, meaning that we've controlled for all other variables. So if we control all of the external variables that could be confounding, then we can achieve internal validity. But that's only when we can say that the cause of our outcome is related to the variables that we studied and not because of something else. Let's take a look at a very basic experimental design. And here you'll see something that's relatively familiar, even if you haven't seen it put this way. This is called a post-test only design. And a post-test only design is when we have two groups. One group gets a treatment, the other one does not, and we test to see what the outcome of the groups are. If we use something very, very simple like medication, let's say we're looking at a medication that makes people smarter. We take, let's say, 100 people. We randomly select a group of 50 to be in the treatment group, and the other group will be in the control group. We give one group of 50 a medication that makes them smarter. It's some kind of super vitamin, probably doesn't exist. Let's say it does. And then we measure IQs at the end of it. And if the IQs of the group that had the pill or the treatment are significantly higher than those that didn't have any treatment, then we can say that the pill had some kind of significant impact on the study. That's good. We would have a significant result. So we have an independent variable, and it would be called medication, and you would either be in the medication group or not in the medication group. And the dependent variable, which is our outcome, would be the IQ score. So we would say that the group that you belong to, the medication group, either the medication or no medication, would have an impact on the outcome or the dependent variable IQ scores. In this case, we can graphically represent it by saying R. R means that it's a randomly selected group. So you have one randomly selected group that's going to get the treatment, which is X. And then we have another randomly selected group that is not going to get the treatment. So there's nothing there. There's no effect. And then we measure the outcome, which is represented by an O. So the outcome is from the dependent variable, which is IQ scores. And we have a post-test only. We have a treatment and a post-test to see if the treatment has an effect, and that's it. Now, there are cases where there are selection differences, and that's a good term to know. We can accidentally subject some groups to a treatment group, some individuals to a treatment group, and those individuals in the treatment group could be naturally smarter than those not in the treatment group. We could just randomly select people and accidentally select more smart people to the control group, to the treatment group. And if that's the case, then we would accidentally think that the treatment was based on the medication when in fact we randomly selected smart people to that group. On the other hand, we could accidentally randomly select people to the control group, and if the control group had the same outcome as the treatment group, we might think that the pill doesn't make a difference, when in fact it might make a difference, but we happen to accidentally select smart people to the control group. So the selection differences must be accounted for. So in order to determine if there are some selection differences, we need to do a test before to see if there are already differences between the groups. And that brings us to the pre-test, post-test design. So in a pre-test, post-test design, we are testing the groups before the treatment and after to determine if there are differences. Ideally, we have two groups that have the same outcome before we get started, and then we give one group the treatment, and then the treatment outcome is different if there is an effect somewhere in the treatment group. That's the general idea. So we can first test to see if the groups are the same, give one group a treatment and one group nothing, and then test the outcome to see if the groups are different that way. Usually we don't need to do a pre-test as long as we have a large amount of people in each group. So let's say that we had 20 to 30 randomly assigned participants. Generally what we can say then is that if we have that many people in each group, if let's say we had 30 people, if we had 30 people in each group, generally if there are differences, the differences between the two groups have been spread equally between them just through random chance. If we had, let's say, 100 people in each group, there's virtually no reason for us to do a pre-test design unless there is some compelling reason, like the treatment effect is important to note in the beginning. And we'll talk about some reasons for that as well. As an example, here's a way that we might do a pre-test, post-test design using a research question: does a psychoeducational intervention increase life satisfaction? That's interesting. Can we teach people something about life in order to increase their life satisfaction? Well, let's look at this example. We have two groups of people. One group is going to be taught about making the most of life, which is kind of this intervention that we're going to subject them to. So maybe we can simply teach a group how to experience life differently and how to make the most of life. And that might increase their quality of life. And we're going to use the quality of life inventory to measure quality of life. We call it the QOLI. The quality of life inventory is a real inventory that measures quality of life and is able to determine what areas of life you are dissatisfied in. Yay! Generally, we can talk about what kind of things that we're not doing well in life, but the QOLI does a pretty good job of identifying which domains it belongs to. After we had both groups take the quality of life inventory for the first time, one group goes through the making most of life intervention, then they're both given the QOLI again to measure the differences. Now here's what we expect out of the control group. We expect the control group to have some kind of quality of life measurement on average. So the first group averaged a 4, and after the treatment, which they didn't receive, but in a second administration, they received a 4 again. So it didn't change, which we expect because there was no treatment. The first group might have a 5, and that's okay. They don't have to match. All we're looking for is what the change is. So let's say the first group had on average a 5, and it's just because on average people experience life a little bit better in that group, and that's fine. Then we gave them the Making the Most of Life seminar, and then afterwards they took the quality of life inventory again, and they on average scored an 8. That's a change of 3. So that means that after the seminar, their rating went up by 3 points. That is probably significant, whatever we're measuring. But the purpose of this was to determine that there is a significant change overall and that there weren't differences to begin with. So if there were significant differences to begin with, we would be focusing on this change. Let's say, for the sake of the example, that we had the control group started out with a quality of life of 3. If that's the case, then the change would be 1. And that may not be expected. So there was a change in 1. So something happened between these two administrations where they went up by 1. What we would be looking at is what the differences in the changes are. There was a more change in the top group, in the group that had the treatment, than in the bottom group in this case. So we could still determine that there were significant changes going on. And that means that if we took the first group minus the second group, we would see that there was a change of 2 in the first group. So there would still be a significant difference between those two groups, and we noted that because we were measuring the overall change that happened between them. Okay, I'm going to reset this so that it looks right for next time. Let's take a look, though, at another type of experimental consideration, and that's the advantages of the pre-test, post-test design. So the advantage of the pre-test, post-test design is that we get to see if the experimental groups were equivalent to start with. At the very least, we're able to then determine what the significant differences are after we look at the final outcome. It's really good for measuring change, and what it can also assess is what we call mortality or attrition, which is dropout in the experiments. So if we have 10 people in the first condition and only 5 in the second condition, let me clarify that. If we had 10 people in the first administration, so if we measured 10 people in each group to start with, and 5 people dropped out in one of the groups and we only had 5 left, we can control for that difference because we took the pre-test, post-test design. It's important to be able to know who drops out, because if people have certain characteristics and they drop out, it can impact the study. So we want to know that. Really, that's not a strong consideration in a lot of studies, because we would hopefully plan to have the same people in the first and second trial. And if they weren't, then we'd have to figure out a way to counterbalance differently. It becomes very complex when we do that. So I want you to focus on the first 2 advantages rather than the last one. Some disadvantages is that it's time consuming. When you have to measure people twice, it takes twice as much time. It can also be awkward to administer, because for the second group, the control group, they're getting 2 outcome tools. So they're getting tested twice on the dependent variable with no intervention. So to them, it's like taking the same test twice without any real change between them. It's kind of awkward. What it also does is it sensitizes participants to what is being studied. If we had a group that took the quality of life inventory twice, they kind of know what they're asking, or kind of know what we're asking, and they know how to answer it. So we need to be careful to make sure that we are doing something, that's too vague, that we are testing the outcome in such a way that the results are meaningful, and that we're not just simply keeping track of how people do on the same inventory twice. We can usually do that by using an alternate form of the same test. We've talked about alternate forms designs in a prior chapter, but what we could do is we could have a quality of life inventory where we only ask half of the questions the first time and then ask the other half of the questions the second time, so that they are similar in the types of questions that we're asking, but they haven't seen the exact same test both times. A design that we can use to test to see if the pretest has an impact on the outcome is called a Solomon 4-group design. So the Solomon 4-group design looks like this. Let's say that there is an impact that the pretest might have, so that people might learn how to take a test or might learn the inventory during the first administration and then be able to answer it during the second administration only because they took it the first time. So they learn something from it. They know what to expect. They know how to answer it. We can test to see if that makes a difference by using the Solomon 4-group design, which requires 4 groups to do, which really just quadruples the amount of work that it would take normally. So we have one group of participants that goes through a pre-test, post-test design. So they're given a pre-test. So let's say that this group is measured on their quality of life. And then we are given one group the Making Most of Life seminar. And then the second group doesn't get anything. Then we measure the outcomes to see if there is a difference there. The other group is only given either the experimental conditions, so the Making the Most of Life seminar, or not, and then we're measuring their quality of life on the outcome. Ideally, the difference between the experimental group and the non-experimental or control group in this design, in the post-test only design, will be the same as the pre-test, post-test design. If that's the case, then the pre-test didn't make a difference. If it's not the case, then the pretest did make a difference, and it's interesting to know that based on the fact that the post-test trend for the post-test only group will be different than the post-test trend for the pretest post-test design groups. Reluctantly, I'll show you this because sometimes it can be confusing. So let's say that there is no pretest effect. Let's say that the pretest did not make a difference. If that's the case, then the groups that had the post-test only, the control group will have a score of whatever it is. Let's say it's 3. And the experimental group will have a score of 7. If the pretest did not make a difference, then the outcomes of this group will be the same as the pretest post-test group. Okay, if that's the case, then there is no pretest effect. The pretest didn't make a difference. The outcomes are similar no matter if there was a pretest administered or not. If the pretest did make a difference, then the trend in the post-test only group will be different than the pretest only or the pretest post-test group. Meaning that if there is no difference in the two groups in the post-test only, so let's say there was no pretest and there was the no difference between the post-test only condition, that means that the treatment didn't make any difference. But for the pretest post-test group, there is a difference between the two groups, meaning that the groups were probably not equivalent to start with. There was something different about the groups to start with, and we can know that because if there was no pretest, there would be no difference between the groups. Now, we have to make a decision when we are doing experiments how we assign each person to a group. We have two basic choices. One of them is called the independent groups design, meaning that each person is assigned to a different group. That means that one person cannot be assigned to both groups. That would be a situation where we are looking at the difference between two groups to see if there is a difference in their outcome based on some kind of experimental condition. Okay, just think of it as two different groups. A repeated measures design is when we have one group of people that we measure twice. Let's look at it this way. If I wanted to see if there was a difference between the GPAs of freshmen and seniors, I could do it one of two different ways. I could use an independent groups design where I could look at the GPAs of current freshmen and then I could look at the GPAs of current seniors to see if there is a significant difference. That would be an independent groups design, or what we also call a between subjects design. We're looking at the differences between two groups. I could also answer that research question using a repeated measures design. If I wanted to see the difference between freshmen and seniors, I could do that by looking at the GPAs of freshmen, waiting until that group were seniors, and then looking at their GPAs then. That's a repeated measures design where I am looking at the same group twice and looking to see if there is a difference in whatever I'm measuring, in this case is GPA. It's called a repeated measures design because we are repeating the measure with the same group. We can also call it a within subjects group because within subjects design because we are looking at the change in the scores within the same group of people. When we are considering how to assign people to a group, our best chance at ruling out systematic changes is by using random assignment. If we are going to have a systematic change or a systematic bias between the two groups, it's because there is something about the characteristics of the participants that are more prominent in one group or another. Let's say that I wanted to do a research study that looked at the differences between two groups of people and their opinions of Olivet College. And let's say for the sake of argument, I just wanted to randomly assign 100 people to two groups, and I wanted to ask them all the same questions to see if there was a difference. Now, if I randomly assign people to two groups without any other characteristics, I would expect the groups to be the same. Because if I'm randomly assigning people, I'm not taking care to see if they're freshmen or seniors, if they live on campus, off campus, nothing. I'm just randomly assigning them. The idea of random assignment is that if there are characteristics that will make a difference, I will randomly assign people to two groups where theoretically anything that would be different between the two groups would be spread equally between the two groups. So there will be characteristics of people within each group that would make a difference, but those characteristics would be shared equally across the groups. So when we randomly assign people to groups, we can prevent systematic biases. We will yield equivalent groups. They're not going to be perfect groups that have nothing going on with them, but whatever is going on within the groups will be equal across the groups. And what it usually does is it removes participant differences as explanations for the results. Remember, the goal of doing an experimental design is to remove alternate explanations. And if the explanation for an outcome is because one group has a bunch of seniors in it, that's no good. We want the explanation to be what we are controlling for with the treatment of those groups, not because there is something characteristically different about the groups. We want to remove that, and the best way we can do that is through random assignment. Some of the advantage of the repeated measures design is that there are fewer participants. We can use participants for the same outcome twice, so we don't have to get twice as many people. And what's also nice is that we can find statistical differences better with the repeated measures design. There's a lot of mathematical theory that goes into that, but just suffice it to say that it's easier to consider your statistical results as valid when you have repeated measures design than if you have an independent groups or what we call a between groups design. There are some disadvantages, though, of doing a repeated measures design, and they all relate to the order effect. If you have one group that is going through a treatment twice, it might matter which order they go through their treatment in. Let's take a look at, or just kind of walk through an example of what that might look like. Let's say that you want to give a group of people some kind of help on completing the SAT. So what you do is you have the group of people take the SAT, and then what they do is they go through some kind of seminar that teaches them how to answer questions and how to write essays and things like that. Then you have them take the SAT again. And you think to yourself, wow, the SAT on the second attempt was much better, so that must mean that the seminar made a big difference. Well, you might be wrong because of the practice effect, because they learned how to take the test. When you learn to learn something, that's a practice, it's a trial. And that alone can make you better at answering the questions. So that means that probably the seminar has something to do with it, but you can't rule out the fact that there was a practice effect there. On the other hand, let's say that in the morning the students took the SAT, at noon they took the seminar, and then in the afternoon they took the second SAT to see if the seminar had an impact. What happens if the second SAT scores are much lower? Well, you might say to yourself, gee, the seminar really didn't have much help at all. Actually, it may have hurt the students. Or they were subjected to the fatigue effect where they just got tired or bored or something, and it led to lower scores. It had nothing to do with the seminar. They were just tired of taking the test. Another disadvantage is the carryover effect. And in the same situation, let's say that the students took the SAT in the morning, and then they went to the seminar and they took the SAT in the afternoon, but the SAT in the afternoon had some same questions that were from the first one. Now, if that were to happen, their scores would be better, and you might say it's because of the seminar, but the carryover effect is probably more at play, to where there is some kind of influence from the first trial to the second trial. These disadvantages are considerations that you have to take into account, and what we can do in order to eradicate the effects of the order effects is to counterbalance. And here's what that looks like. When we counterbalance, what we can do is we can switch the order that the independent variable is presented. What that means is that we can split our experiments into two groups. We can have one group go through the first intervention and then get tested, then go through the second intervention and then get tested, and that will determine what the differences are. In order to eliminate any kind of order effect, we have the second group go through the second intervention first. We test them on whatever the outcome is. they go through the first intervention, and then we test the outcome. The outcomes should be the same at the end of all the trials between the two groups. If they are, then the order doesn't matter. If there is a difference in the outcomes at the end of all of the trials, then there is an order effect. That means that there is some kind of order effect occurring, and it takes a lot more analysis to figure it out. I debate on whether or not to talk about the Latin square because it's really just a matter of assigning people to conditions, but I'll just show you the Latin square and kind of briefly tell you what it's about. Let's say that we had 4 conditions, so 4 interventions that we were introducing. If we wanted to make sure that each group went through each possible order of those 4 variables, we would be in trouble because there are a lot of combinations. But what we can do is we can use this Latin square, and we can assign one of each of the 4 groups to one of these conditions, and it will go through approximately half of the possible conditions. And when we do that, we will get all the order effects eliminated. It's really unlikely that we're going to deal with this in any reasonable situation with regard to experimental designs, but it's in the book, and I feel like covering it or at least mentioning it is an okay thing to do. But again, we're not going to spend a lot of time on that. So the question is now, how do we choose between independent groups and repeated measures designs? Well, it comes down to what you want to do and what's practical for you. The advantages of the repeated measures designs are often outweighed by their disadvantages. Most of the time we're going to go with an independent design, meaning that we're going to use multiple different groups of people. Most of the time it's simply because we don't have the time to do multiple experiments with the same group of people over and over again. Only when it's necessary from a experimental standpoint do we use the repeated measures design. There are some real-world situations that are comparable to independent designs, but some most closely resemble the repeated measures designs. When we have to make a choice and it really doesn't matter, we'll go with the independent samples design. If we must go with the repeated measures design, then we do it. But generally, we will go with cross-sectional designs, which are the independent designs, more frequently than longitudinal designs. When we are producing relatively permanent changes, we can't use the repeated measures designs because you can't undo changes if you have to do, if you have to do counterbalancing. So if we find out that the order that we introduce the stimuli makes a difference and it's going to lead to permanent change, like in a drug trial, you can't undo that order effect if you've already done within, it is still within, but a repeated measures design. So generally, experiments that are going to lead to permanent change, we use an independent design. That way, if there is a permanent change in the experimental group, we can apply that same intervention to the control group without having lost anything from it. Okay, we're going to stop there. I'm not going to go through matched pairs design. It's a little bit more specific than I feel like we need to get into in this class. But suffice it to say that we've covered quite a bit and as far as experimental groups are concerned. And what's interesting is that we've only covered like 3 different designs. I guess if you classify the repeated versus independent design as 2 different ones. But we've talked about the pre-test only, the post-test only design, the pre-test post-test design, and the repeated measures design, where we looked at how we counterbalance. So those are really the 3 different kinds that we've looked at. Experimental designs do tend to be pretty daunting when we try to develop them because there's a lot of considerations. Don't let it stop you from doing it, but just know that we tend to stray away from them if we can look at existing differences, which are mostly what we're trying to do in social research, is to find out what the differences are among groups that have pre-existing conditions. So that's all for experimental designs. Take a look at the article response. I look forward to seeing what you can do with that stuff there. And if you have any questions, as always, feel free to reach out.